So I truly never imagined when starting my PhD that part of my thesis would be focused on studying the chemistry of why poop smells bad. But that's exactly what I've been working on lately, and I can tell you it's actually a really fascinating topic. So, in all honesty, we accidentally stepped into this project. You see, our underlying fascination lies in the human gut microbiome. We like to think of ourselves as autonomous human beings, but in reality, we actually have more bacterial cells in us than human cells. And the bacteria that inhabit us are performing a wide range of chemistry that impacts mammalian health. The large molecules that perform these reactions are called enzymes. And during graduate school, one of my main goals has been to help identify new enzymes, currently of unknown function, that are abundant in the human gut microbiome. And that's exactly how we discovered IAD, this enzyme that makes skatole, a molecule that is extremely odorous and is one of the main culprits for why poop smells bad. So you might be wondering, why does this even matter? And I had the exact same question at first. So I was really surprised to learn that the agricultural industry has been searching for this enzyme for a really long time. Why? Three main reasons. First of all, zoning regulations. So there are currently very strict zoning regulations for how far communities must be from farms based off of smell. And secondly, a phenomenon called bore taint. The degradation of skatole in the liver is actually inhibited by the hormones testosterone and androsterone. So skatole can actually accumulate in boar tissue, making perfectly good meat smell spoiled or tainted. Lastly, skatole is actually toxic to lung cells in cattle, causing fatal diseases in these animals. Currently, the only solutions we have are to castrate boars and keep cattle on what are referred to as low skatole or essentially just low protein diets. If we could find a way to just inhibit IED, however, the enzyme that creates skatole, we could potentially solve all these issues. In order to design an inhibitor, however, we first have to understand how IAD functions in the first place. One way we can gain insight into how an enzyme functions is by using a technique called X-ray crystallography. With X-ray crystallography, we can basically take snapshots of our enzymes. We can take pictures before IAD performs its chemistry, while it's in action, and after it's formed skatole. And then we can start to piece together how IAD gets the job done and how we can stop it from doing its job and inhibit skatole production. As of now, I've solved an initial structure of IAD, and I'm currently working to get a higher resolution structure so we can really understand at the atomic level how IAD functions and start designing inhibitors. Overall, this has been a really fun project to work on, and hopefully with this work, we can help make the world stink just a little less.